Let's start with a question that gets right to the heart of our digital world. Can a computer, a machine built on pure, predictable logic, ever do something truly random? The answer, as you're about to see, is way more important than you might think. And to show you why it matters, let's jump straight into a high-stakes game. Imagine you're playing online poker. The pot is huge. You're waiting for that final card. But what if I told you your opponent could figure out your entire hand just by knowing how the virtual deck was shuffled? Now, that might sound like something out of a movie, but this exact thing really happened. An early online poker site had a major flaw, and it wasn't a magic trick. It was just bad math. So let's break down exactly how this digital card trick was pulled off. Okay, so here's how it worked. The server starts the shuffle with a single number called a seed. Now, 4 billion seeds, it sounds like a lot, right? But for a computer, it's nothing. An attacker could figure out the shuffle for every single one of those seeds ahead of time. So the second you get your first card, bam, the attacker already knows it could only have come from a much smaller group of seeds. And with every new card you get, they slash the possibilities. After just 5 cards, they've basically got it narrowed down to maybe 20 possible decks. They pretty much know what you're holding. Game over. So here's the real kicker. It wasn't about bad luck. If you looked at millions of hands, the stats would probably look just fine. The real problem, the fatal flaw, was that it was all predictable. And in security, predictability is the absolute worst thing you can have. And that poker game, it's the perfect example of a much bigger, much more fundamental issue in computer science, the pseudo-random problem. You know, MIT professor Steve Ward put it perfectly. Computers are deterministic. They are literally designed to follow instructions perfectly, to give you the same answer to the same question every single time. They're built to eliminate randomness, not create it. So to get around this, computers use a clever trick called a pseudo-random number generator, or PRNG. Think of it like a really complex recipe. You give it one starting ingredient, that's the seed, and the algorithm spits out a long list of numbers that looks totally random. But here's the secret. If you know the recipe and you know that first ingredient, you can create the exact same random sequence. It's not random at all, it's just a pattern. And sometimes you can actually see these hidden patterns. Back in the day, some researchers visualized the so-called random numbers being used online. They expected to see just noise, like static on an old TV screen. But instead, they found these clear, repeating patterns, basically showing everyone, hey, this isn't random at all. So this really brings us to a fork in the road. On one side, you have these pseudo-random number generators. They're based on algorithms, they're predictable, and they're really just faking it. But on the other side, we have something completely different, a true random number generator. So if a computer can't create randomness on its own, where in the world can it find it? Well, the answer isn't in the software. It's out here, in the messy, chaotic, unpredictable physical world all around us. And the key ingredient it's looking for is something called entropy. Now, that's just a fancy word for randomness or disorder. True random number generators are designed to find this entropy, to listen to the background noise of the universe and use that chaos to create numbers that are genuinely 100% impossible to predict. And where does a computer find this chaotic energy? Oh, you'd be surprised. It can come from atmospheric noise, like static from a lightning storm halfway across the world. It can come from the tiny heat fluctuations inside its own chips. It can even come from you, the microscopic delays between your keystrokes as you type. And then there are the really creative sources, like Cloudflare's famous wall of lava lamps, where they literally film the chaotic flow of wax to generate pure, beautiful randomness. So the whole idea is pretty simple, but it's also brilliant. You can't predict the exact chaotic movement of every molecule in the room, right? Well, by measuring these tiny physical events with extreme precision, a computer can capture a stream of data that is truly, fundamentally unpredictable. Okay, so it seems obvious, right? Just use true random number generators for everything. Problem solved. Well, as it turns out, it's not quite that simple. In the real world, the best solution is actually a clever mix of both. Here's the catch. Generating true randomness is slow. It's computationally expensive, meaning it takes up a lot of processing power. If you have a massive web server that needs billions of random numbers every second, it can't just sit around waiting for a lava lamp to do its thing. And this is where we get the best of both worlds, the cryptographically secure pseudo-random number generator, or CSPRNG. Here's the genius part. It starts with a small amount of very high-quality true random data, R entropy. It takes that as its seed. Then it uses a super strong algorithm to stretch that little bit of perfect randomness into a massive, unending stream of numbers that's just as unpredictable as the original. And modern systems, like the Linux operating system, don't even trust one source. As its creator, Linus Torvald, says here, they basically throw everything into a random pool. They mix together entropy from the CPU, from network activity, from disk timings, you name it. The idea is that the final mix is way stronger and more unpredictable than any single ingredient. If one source fails, the others pick up the slack. Okay, we've gone from rigged poker games to lava lamps and cryptographic algorithms. So let's bring it all about home. Why does any of this really matter to you in your everyday life? Because at the end of the day, it all comes back to this one single idea. For security, what matters isn't a perfect statistical spread. What matters more than anything else is unpredictability. It's the one thing that keeps an adversary from guessing what comes next. And this isn't just some abstract theory. This is the invisible engine protecting you online every single day. You see that little lock icon in your browser? That's powered by this. Your online banking transactions, secured by this. Your private encrypted messages? You guessed it. It's the silent guardian making sure the internet can be a safe place to be. Our entire digital world is fundamentally built on keeping secrets, and those secrets are only as safe as the unpredictability that protects them. It's this constant search for new, untouchable sources of chaos, which leaves us with a final thought to chew on. In a world that we're constantly trying to make more logical and orderly, where are we going to find the next bit of randomness we need to keep everything safe?